Okay, I'll start the recording. I'll share the screen that to get refreshed. I think you can see the screen. That's what we discussed last day. Can you hear me?
Yes, sir, we can hear.
Thank you. If you have any question, then you can ask anything that other things we have discussed there. And after that, we came to this section. Then there we discussed that additional tools we need to enhance our circuit designing. Then we discussed several laws and theorems there. Then after that, using those tools, additionally we discussed, we rearrange our equations like this. Then we realized that after rearranging these equations, then the resultant equation is having the simplified version of that one. Then to implement that one, we need less number of gates than previous one. Okay, because of that, we wanted to do like that. Actually, doing that one is minimization of Boolean equations. Then there I mentioned that these are the two methods we are going to use for the minimization of Boolean equations. Then first method using Boolean algebraic method we discussed like this. And we tried this last year paper also, last year paper question also. That was the thing we have discussed last day. If you have any kind of question coming from those sections that you can ask now, or otherwise that this is the way that we have to use this Boolean algebraic methods to minimize equation. Okay. If you are okay with this Boolean algebraic methods for the minimization, then we can move on to next section. Anything to be discussed? Anything you didn't understand? Okay, fine. Then if you are okay with this, then we can come to the next section. That means that using Carnot method, we can minimize our equations. Okay. Actually, this is a graphical representation of Boolean equations. It's not like previous method. Previous method we use that Boolean algebraic methods for the minimization. So it depends on most of the time that the points you have started and the considered terms and the experiences you have gained. Like that, when you have several other factors. Okay. Then, but when you consider this method, this is some kind of graphical representation of Boolean equations. Okay. Then okay. Then we can use then Carnap method. Okay. You know that when we have a Boolean variable, it's having two states, A and A bar. Okay. Then for the representation of this one with this Carnap method is having two squares like this. Okay. This is for A bar and this is for A, like that. Then the technical term for this one is a grid. We don't say squares, but it's a grid. We have two grids there, but here we don't have point to discuss there. Shall we move to the two variables? For the two variables, we have consider A and B. Then for this A and B, we have these variations: A bar, B bar, A bar, B, A B bar, A B. Those are the all four options we have for this AB variable, AB two variables. Then here we have this map. Like this. This is side A and this is side B. This is for B bar, for B. This is A bar and okay. Okay, then how can we represent all these things here? For example, if you have a this is the grid for A bar, B bar, and this is for A bar, B. You can see the references. Okay, this side is A is coming, and from top side B bar is coming like that. And this is the way we can find all four grids for all these four combinations. Okay. Shall we directly move into equation? Then shall we try to minimize this equation? F equals A bar B bar, A bar B, and A. Okay. Then how can we minimize this one? First thing that we have to mark this term on the map. Okay. Then what is the first term? It's A bar B. Okay. And here, because we have A bar B bar, because of that, we mark 1 here. This is A bar B bar grid. Then on A bar B bar grid, we put 1 there. Why? A bar B bar is there in our equation. Next one, A bar B. Here also we put 1. Third one, AB, like that. Then for this grid, we put 0, indicating that that term is not with our equation. Okay. Now we have to minimize. How can we minimize? We have to group these ones together. Adjacent ones you can combine to make a group. Okay. Then how can we group these things? We can make a group like this. Okay. What are the possible groups that you have? That you can have that this horizontal groups. That is okay. This vertical type of groups, it's okay. Squares or rectangles, that is okay. But diagonal groups, like that, these are not allowed. Okay. Then we have marked these two ones together. Then what is remaining? This one we can take alone. Then try to give a name for this one. What is the name for this group? It's on this entire A bar row. Then we put A bar here, showing that we have taken the entire A bar row for our grouping. And what about this one? This is standalone one, AB. Okay. Then we can write this minimize equation now. F equals A bar plus AB. Now previous equation. This is the previous equation. Now this is the minimized one. Is it okay? Okay. Sorry for the disturbances. Then what about that? This is our Kahneman. Okay. for this particular function. But there we make this horizontal group covering this A bar row. But what about that if we do it this way? It's okay. It's a vertical group. It's allowed. And we can take it along. Then try to give a name. If it is possible to give a name, that means that we have done correct thing. This is B. Then what is this? This is A bar B bar. Then new equation for the second Karnaugh map is previous one, you may remember, is A bar plus AB. Now this time this is B plus A bar B. Different equation, but function wise both are giving same thing. Okay. What about that? But actually that we have done the second case, we have done this vertical group, and the first one we made this horizontal group like that. Can't we join all these two groups together? For example, I'm asking that first we made this first equation. The second one we made this horizontal group. Can't we do this same thing at the same time? Two things at the same time? For the moment, assume that we can do it. Assuming that this is allowed. What we have done, we have covered this one 2 times. That's what we have done. Here, what is this? This is B. And what about this one? This is A bar. Now see that what is new equation? New equation is A bar plus B. Okay. Then this is our third equation. This is our second equation. This is the first version. 1, 2, 3. Which one is the best one? What do you think? Which one is the best one? Third one, second one, first one. You have 3. I have 2 answers. One is saying third, the other one is saying first one. Okay, 3. For number 3, we have many votes. Okay. Actually, that why number 3 is good, because here we need A, B, and it's a more simplified version. You can see at number 3. Because of that, actually, that's number 3 is the good one. Then to receive that one, what we have done, we have covered this. We have covered this grid 2 times. Our question is it possible to cover this one 2 times? When you consider equation, what we have done here? When you consider equation, what is our equation? F equals A bar B bar plus A bar B AB. Then covering this A bar B 2 times means actually we think that we have this one again. A bar B twice, 2 times. Then from these two, we are receiving A bar From these two, we are receiving B. Then to do that, we need this A bar B again. Is it okay? We are going to do some kind of minimization, but to do that, we have added another term there to the equation. Is it okay? Yes, no problem. Why? Do you remember this one? What is A plus A? It's A. Then what about A plus A plus A plus A? Again A. Then for this operation, if you repeat one terms many times, it doesn't matter. Okay. Then this is the first rule of Karnaugh maps. One grid can be covered many times if it helps minimization. But this is not a must. It is not necessary to cover one term many times. But if you think that this will help for the minimization, you can cover. Okay. Then you can cover it. Then this is the first rule of Karnaugh maps. Okay. Then one grid can be covered many times if it helps minimization. Okay. At the same time, we learn how to minimize using Karnaugh map also. When you have a two variable equation, first thing you have to mark those terms on the map. After that, make groups, trying to make large groups as much as possible. And if you need that, you can cover one term many times and find the last solution with minimal result, with minimal number of terms in the equation. Okay, that's what we need. Okay, then if you're okay with that, then shall we move three variables one? When you have three variables, that means A, B, C. How many grids should be there? How many combinations are there? 2 to the power 3, 8 combinations. Then we need 8 grid map. Okay. We need 8 grid map. This is side A, and this is for BC. Here we have A bar A, and this is B bar C bar, B bar C, BC, and BC bar. Think about this one. We have changed the order. You can see we have changed the order. We change the order. It's not, normally we are writing B bar C bar, B bar C, BC bar, and BC. See this order? This is the way normally we are writing, but we have purposely changed this order here. Why? Because that is the second rule of the Karnaugh map. Okay. This is the second rule of Karnaugh map. What is that? Shall we put the values of this one? What is this? This is 0. This is 1. This is 0, 0, 0, 1, 1, 1, 1, 0. Then what is this? 0, 0, 0. This is 0, 0, 1. This is 0, 1, 1, 0, 1, 0, 1, 0, 0. 1 is coming from that side. 0, 0 is coming from top. Then this way, 1 from top, 0, 1. This is 1, 1, 1, 1, 1, 0. You can see this 0, 0, 0 has changed 0, 0, 1. Only one bit change. 0, 0, 1 became 0, 1, 1. Only one bit again change. 0, 1, 1 to 0, 1, 0. Again one bit. From downside, 0, 0 to 1, 0, 0. Again one bit. Okay, then because of that, we have to follow this pattern. Actually, it is not necessary to follow this pattern. But whatever the pattern you like that you can use. But only the thing you have to consider from one grid to next grid. It's horizontally or vertically. It doesn't matter. But you can change one bit at a time when you go to the next grid. Okay. Because of that, we stick to this pattern. But if you want, you can have the different one. But this is correct. This is not. Okay. Keeping that one in mind, that shall we try to implement this one using another example? Yes, why that is wrong? Ajay, actually, as I mentioned here it's wrong because that if you put this way, we are not obeying the second rule of the Karnaugh map. That is that when you move to one grid to next grid, adjacent grid, you can change only one bit at a time. Okay. Shall we put this on? Yeah. To explain it, shall we put this way? B bar, C bar, B bar, C, B, C bar, B, C. Assume that we have done this way. Then what is the value? 0, 1, 1, 0, 1, 1. Then shall we put those values there? This is 1, 0, 0. This is 1, 0, 1. This is 1, 1, 0. This is 1, 1, 1. From top, this is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1. Okay, when you go from here to here, 1, 0, 1 became 1, 0, 1. It's okay. Then this 1, 0, 1 change to 1, 1, 0. This is 1. It's okay. But this 0 has changed to 1 and this 1 changed to 1, 0. Then 2 bits we have changed. Because of that, this is wrong. Here to here, 1, 1, 0, this is okay. But here we have done a mistake. Because of that, this red color one is not correct. This is wrong. This is wrong. Is it okay, Ajay? Yeah, because of that, we can't follow this pattern, but you can have this pattern here. Okay. So shall we try another example here? Then A bar, B bar, C bar plus A bar, B, C bar, A bar, B bar, C. A, B, C, A, B, C. Okay. Shall we try this one? Which one is okay? Sorry. Then this should be A bar BC. Okay, thank you. Okay, how can we mark this one? A bar, B bar, C bar. It's here. A, B, C bar. A, B, C bar is this one. Then A bar, B bar, C is this. A, B, C, and A bar, B C bar, and we put zeros for this. How can we mark? This one. And what is this group? This is A bar. We need support from A bar because it's on A bar row. Then we need support from these two coming from top. And what is that? It's B bar. Okay. Then we have to mark this one. And what is this? This is A, B. Okay. Then we can combine these two together like this. And what is this? This is B, C bar. This entire column we have taken. Then we can write, minimize the equation there. Equals A bar, B bar, A, B, and B, C bar. Okay. Actually, when you consider this one, then you can see that here, this is A bar. This is A. But what about this one? These two. This is B bar. This one. This is B. Here for A bar also you have 4 grids. A also you have. For B bar, these two columns, when you take these two columns together, that is B bar. These two columns together, that is B. And not only that, what about if you consider these two columns? This is C. And these two columns together, that is C bar. Then we have to combine these two together. Okay. You can see that here B bar, C bar, here B bar, C. When you consider these two columns, B bar is common for all these two columns. Then when you say B bar, that is these two columns. Here, when you say B, these two columns. When you say C, it's this. Okay. Shall we try another question? This is A bar, B bar, C bar, A, B, C bar, A bar, B, C bar, and this is A, B bar, C bar. A, B, C, plus A, B bar, C. Shall we try this? Okay, did you try this one? It's here, A bar, B bar, C bar is here. And A, B bar, C bar is here. A, B, C, A bar, B, C bar is here. A, B bar, C, and A, B bar, C. Okay. Then, how did you make groups? It's very easy that you can make this group. And what is name? Name is A. What about this one? These two, you can make a group like this and group like this. But anyway, that can't we do this way? You can consider these two ones with these two ones. How can we do that one? You can take this edge, rolling this map, you can take this edge here. Then you can consider this as a cylinder. It's a vertical cylinder. Then this edge can be taken here. Then if you do like that, these two ones and these two ones, they are close, they are adjacent. Okay, shall we try to give a name for this one? If it is possible to give a name, that's we have done correctly. What is name for this one? That is C bar. When you say C bar, it's this column and this column. Here. Yes. Then now minimize equation is F equals A plus C bar. This is our minimize equation. Is it correct? Do you have any other variations? Can you check your one? Okay. Sometimes that you have marked these two groups together separately like that. It doesn't matter that, but you can do. Then you, with this, you are learning the third rule of Karnaugh maps. What is that? Edges can be connected. Map edges can be connected together. Then based on that, if it's possible to make large groups, then do it. Okay. Shall we try another one example, one, two examples like that? Then we can finish this one more. Okay, try these two. If you're okay with these two, then we can go for the next section. Okay, shall we try this one? This one, then A, B bar, C bar, A bar, B bar, C bar, A bar, B bar, C, A, B, C, A bar, B, C bar. Okay. Then how can we make groups? We don't have any option then to cover this one, we have to make this group. Okay, then this is B bar, C bar. And to cover this one, again, there is no other option. Then this is A bar, B bar. Okay, then this one. To do that, we have to cover this way. Then this is A bar, C bar. Okay, this is A bar, C bar. But what about this one? No option. Okay, because of that, we have to take it along. This is ABC. Okay, then new minimized equation is G equals A bar, B bar, B bar, C bar, A bar, C bar, and ABC. That's it. But what about this one? Okay, this one. Do you mind showing the previous answer? Okay, the previous answer is this one. Okay. And this is A bar, B bar, C bar, and A, B bar, C bar, A bar, B, C, A, B, C. Can we minimize this? No, it's not possible. Then how can we do it? Okay, we can do it like this. Then when you consider these two, then we can take B bar out. Then inside that we have A bar, C bar plus AC. Plus there we can take B out. And inside we have A bar C plus AC bar. Okay. Then this is exclusive no. This one exclusive O. Okay. Then this is B bar A exclusive C plus B A exclusive C. Then for this we can write A exclusive C B. Is it okay? It's something like this. Then this is, we can take this is D, then this is D bar. This is D. So then what is this? This is B bar D bar plus BD. When you have this type of thing, then you can write this is B exclusive D. Oh, sorry. D. Then you can replace D by exclusive C. Then this is B exclusive O. For D, you can put A exclusive OC like that. Then for this type of one, from Karnaugh maps, we don't have any solution. Then we have to go for Boolean algebraic methods. But 99% we can use Karnaugh maps to get a good result. But for very few cases like this, for example, if you have a diagonal maps like this, okay, it may be something like this, it's diagonal. For this type of zigzag maps, we can't have a solution from Karnaugh map method. Is it okay? In question 5, there is two grouping possible. We can question number 5. Question number 5 that that you are mentioning that two grouping possible. How can we make groups there? Question number 5.
Excuse me, sir.
Yeah.
Sir, there should be a 1 on A bar, B, C bar. So then we can make a group according to the question.
Yeah. I couldn't actually, sorry, I couldn't follow you that which grids that you are referring.
No, sir. So I think I got confused with the A bar in the last one. No, sir, it's not possible. Sorry.
Yeah. Okay, thank you. Anyway, thank you for asking that type of question. Then appreciate that you are asking question. Then all of others that take the benefit of that. Thank you very much. Okay, then we can move to the next section. Then targeting 4 variables. Okay, 4 variables. Then we need 16 grid map. Variables are A, B, C, D like that. We have 4 variables. Then we have 16 different combinations. To cover up that one, we need 16 grid map. Okay. Okay, this is the map we can use. Okay, then straight away, shall we try a question? Example. Okay. Can you try this? We can finish this section today. The next day we can start a new section if you are okay with this. Okay, we can try this one. Then shall we try A, B bar, C bar, D bar, here one, A, B, C bar, D bar, A, B, C bar, D bar, A bar, B, C bar, D bar, A bar, B, C, D, A, B, C, D, A bar, B, C, D bar, A bar, B, C bar, D, A bar, B bar, C, D. Is that correct? Is that the map you got? Okay. Okay, it's clear that we can make this group first. This is A bar B, and we don't have any other option to cover up this one. And this is A, C bar, D bar. But we're not in that. ඒක මම කතා කරා එයා දැන් ලිස්ට් එකේ and here this one here to cover this one, we don't have any option other than going this way. And this is A bar, C, D. This one B, C, D. Okay. Then we can write new minimize equation A, C bar, D bar, A bar, C, D, A bar, B, it's B, C, D. Okay. This one A, B, C, D here, then A, B, C, D bar, A bar, B bar, C bar, D bar, A bar, B bar, C bar, D, A bar, C, D, A bar, B, C. A bar, B, C is not a grid. This one is not a grid. It's an area. Again, it's a group. Okay. Okay, then what is A bar BC? A bar BC. A bar BC means this one. Okay. Then how can we make group? You can see this one and make this one. What is this? This is B, C. What is this? This is A bar, B bar, C bar. And here we have one. If you want, you can combine these two together or these two together. Then there will be two answers there. One that if you cover these two ones together, then you will have one equation. But if you group this one with this one, then you will receive different answer. This is A bar CD. Okay. Then our equation is A bar, B bar, C bar, A bar, CD plus PC. Okay. You can try this one. Okay, you can copy this question and try it at home. We can finish up this section next day, and we have to discuss only this one. You can try this one alone and try to find a good solution for this. Okay, any question regarding the section so far we have discussed? Anything, any question? Okay, if you don't have anything else, I think the afternoon you may have that other classes also. Shall we stop the class now? Okay, thank you very much for your time. Thank you very much for your participation, and hope to see you next week again. Thank you very much, and be safe and take care of yourself. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.